Hi, welcome to my talk, How to A/B Test with Confidence, where we'll be learning a lot about A/B tests and some of the things that can go right and also some of the things that can go wrong with them. So this is me, I'm Fred. I'm a long-term Rubyist, so I started with Rails back with 1.0. I'm currently the CTO at Recipe. We do a lot of things at Recipe, but mainly we help retailers personalize their content and be a bit smarter with their data. And as part of that, we run a lot of A/B tests. So comparing our personalization methods with theirs, different types of personalization, different algorithms, improvements to algorithms, and so on. So we've run a lot of A/B tests. And this is my assistant, Luna. She's half pillow, half cat. So briefly, the plan for the next half an hour or so is somewhere between how to do an A/B test and how not to do an A/B test. So we'll start with a brief recap on what is an A/B test, why are we doing these things. Then we'll talk about some of the things that can go wrong. So setting up the test, running the test, and analyzing the test. And then, so that we don't finish on a downer, I'll talk about some best practices. So starting with the beginning, what is an A/B test? It starts when there's a decision you would like to make, and you'd like to make that guided by some data. So maybe you have an e-commerce application, and you're wondering, should the button say buy now or order? These both sound plausible. And rather than just going with your gut, you'd like some actual data. So we'll take our users. We'll split them randomly into two groups. One group will see the buy now button. The other group will see the order button. We'll let this keep running for a few days, and then we'll count how many orders happen in both groups. So in this case, 49 orders, 56 orders. And the real question we have is this difference real? Does changing the text really improve our stats? Was it just a fluke? Before I go into that a bit more, I just wanted to say this is not just buttons. There's often the example that people use when they bring up A/B testing, but you can do a lot more with it. Staying within the realms of UI, beyond just buttons or button text or colors, you can test much more complicated changes to layouts or designs or flows. Maybe instead of the difference between the two just being the text on the button, maybe buy now actually triggers a purchase inside the page, and the other button goes to a separate checkout page. You could test things like that. Algorithms are great, so different recommendation engines, different parameters to them. And really, anytime you can measure a difference, but you want to take that difference into account in a rigorous way, then an A/B test is the process through which you do that. I'm going to need to go through some jargon. So hopefully this will only take a few minutes. And the three terms I want to go over are significance, test power, and sample size. So significance is answering the question, is the observed difference just a fluke? So this is where you'll hear people talk about p-values. And when someone says we got this result and the p-value was 0.05, that means there's a 5% chance it's a fluke. But sometimes people talk about this the other way around. Instead of saying a p-value of 0.05, they'll say that the confidence level is 95%. It's the same number, it's just viewed the other way around. So what happens is you run your test, you get some data, you plug your data into the appropriate statistical test. I don't want to get into the maths here. There are lots of online calculators that will help you with that. But there is a way of doing it for each type of metric. And this is the key thing. The statistical test depends on the type of metric. You'll do a different calculation if you're measuring customer retention rates than if you're doing sign-up conversion or average spend per customer. The math is just slightly different. And the last thing is that significance testing tells you, is there a genuine difference between the two groups? It doesn't tell you anything about the magnitude of the difference. So maybe you run an A/B test and you get conversion at 10% in one group and 6% in the other group. And the maths tells you that this is a statistically significant difference, then you know that there's a difference. It doesn't necessarily follow that the difference is exactly 4%. The twin of significance, the twin brother is, or sister, is test power, which is, rather than looking at do I spot a difference that's not there, it's how likely am I to miss a change that is there? How small a change do I want to be able to detect? And intuitively, the smaller the change you want to detect, the more data you're going to need, the more users. This may seem obvious, but one thing to point out is that it's about the absolute rate as well as the relative rate. So going from 10% to 20% is much, much easier to measure than going from 0.1% to 0.2%, even though in both cases you're doubling the starting number. And a kind of follow on from that is that if you're trying to measure something and your current conversion rate is 0.1%, then it is going to be really hard for you to get a significant result. I mean, if you combine these two concepts, so test power and significance, then you get to sample size. And what the sample size is how many users do you need to put through your A/B test process to be able to detect a change of a certain magnitude with a certain significance level. So you do your calculations, and again, these online calculators will tell you will give you that number. The first thing you should be doing is checking whether this is feasible. If it tells you you need 1 million users and you have 1,000 users, then it's probably back to the drawing board for your test. It's not going to happen. Or maybe there are cost implications. If you were testing a new homepage, do new users to your site like the homepage enough to sign up, and the way you get new visitors is largely driven by Google Ads, then there's a cost to you acquiring 10,000 or 100,000 users. Is that cost worth it? And once you've done this, and hopefully it is feasible, then ideally you want to run the test and not tinker with it, not look at it until you've reached that sample size. I will say be very wary of short experiments. So maybe the results of the sample size calculation tell you need 5,000 users, and you look at your traffic stats and say, that's great, we get 5,000 users in a day. That makes you very vulnerable to transient conditions. So for example, maybe the one day that you happen to run your test on is a national holiday, or maybe it's during the school holidays, and the users that you get during the school holidays are not representative of your overall user base. So if you have a very short experiment, only a few days, then you're vulnerable to be waylaid by this. There is another way of approaching these kinds of, is this test genuine? That's Bayesian AB testing. I don't have enough time to go into this in a lot of detail, but it's generally a different school of thought regarding statistics. And the big difference is that you start with what they call a prior, so a model you have of how you think the world behaves. So you're incorporating your current understanding of the situation, and also the uncertainty you have about that situation. So you take that prior, you update it with the data from your experiments, and your output, instead of just being a number, is a probability distribution. So the outcome of a Bayesian A/B test looks a little bit like this. You have these two curves. These are the posteriors for each variance. And what these curves represent is what the probability of any given outcome is. So in this case, the green curve certainly looks like it's maybe a little bit better than the red curve. It's further to the right generally. And again, this is where you start doing some maths to work out over the entirety of possible things whether the green curve is in fact generally better than the red curve. And what the Bayesian A/B test allows you to do, let's say, it allows you to model your existing knowledge and uncertainties a bit better. You're not starting from zero knowledge. This means it can be better with lower base rates. So when your starting conversion rate is pretty slim. The underlying maths are a bit more complicated though. But say the view of the world it gets is a bit simpler to think about sometimes than classical A/B testing. Everything else that follows in this talk applies nearly equally to both classical and Bayesian A/B testing. So in theory, we know what an A/B test is now. We've gone through some basics. What can go wrong? Unfortunately, things can go wrong from the start. And the most important thing is group randomization. Everything rests on this. If you get this wrong, then all bets are off as to the validity of your test. So about 10 years ago, I wrote this slide, or these few lines of code. I thought to myself, well, we're going to be running some A/B tests. I'm too lazy to write database models that will track which group each user is in. So I know what sounds obvious. Whether your user ID is even or odd, that feels quite random. So maybe I can use that to decide which group you're in. So if you have an even user ID, if ID mod 2 is 0, then you'll get the experiment. And if it's odd, then you'll get control. And this would probably have been just about okay if we'd run one A/B test, but we didn't. We ran a whole series of A/B tests. And if you had a user ID that was odd, then you'd get the experiment, that was even, you'd get the experiment every single time. So towards the end, we're not just testing the individual experiments, we're also testing how do users behave when they receive all the experiments, when the layouts of their pages are changing every single week. Maybe the test is just telling us that if you keep on experimenting, people get tired of constant change like that. You could rescue this code. This is something which is very similar to what Vanity does, which is the great gem in Rails for doing A/B testing. So here, instead of just looking at the user ID, I take some identifier for the experiment, I mix it with the user ID, and I put it through a SHA-1 digest, and I look at the last digit of that instead of the last digit of your user ID. But even this only works if you know that the SHA-1 digest has the right statistical properties. So in general, don't roll your own. It's very easy to have what seems like clever ideas that have significant flaws afterwards. And as I mentioned, this approach of taking the ID of the experiment and the user and hashing them together is basically what Vanity does in one of its modes. Really, any kind of non-random split is going to be a very bad day for you. We once ran an A/B test, or we participated in one that was run by a retailer, and there were two groups, and they weren't random. There was a strong bias to them. The newer users were in one group, and the older users were in another group. And of course, this meant that the newer users, in general, were less loyal. They weren't the people who'd built up over a period of years an affinity with that brand. And so we got some amazing results. But then we looked back and we found that the two groups had very different results before the test started as well. And it's very difficult when you get something like this to extract a result. If there was a 5% difference before the test and there's a 6% difference after the test, you can't just subtract the 5 and say, well, we made things 1% better. You just have a result that you can't trust. So we had to run that A/B test again. Another thing that can go wrong is starting your test too early. And I'll take you through an example to see what I mean by this. So let's say there's a change you want to test on your checkout page. So we follow the process we talked about so far. 100,000 users come to the site over a month. That's our sample size. And I split 50,000 and 50,000. They both get the same homepage because there's no changes there. Some of them click through into the next page on the site. And again, they see the same thing. Some of them click through to an individual product. Again, it's fewer numbers, but it's going to be the same proportion because everyone's seeing the same thing. So 15,000 and 15,000. And then an even smaller subset of those people will actually add it to their cart and go to the checkout page. So let's say 5,000. And then now people are actually seeing different content. So we would expect to possibly see a difference here. And maybe we end up with these numbers, 2,600 versus 2,500. And if you do the maths, this is not statistically significant. We've changed 5% to 5.2%, which if you remember the slide on test power, that's a small difference. It's going to be hard to measure. And kind of intuitively, the reason why this is that out of 100,000 people, 90,000 saw no change at all. The test didn't make any difference to them. And so that's why the test is saying that overall there was no difference, no statistically significant difference. So what else could we do? Well, 100,000 users come to the site. Let's not put them into the A/B test yet. On the homepage, they're seeing the same thing. Some of them, again, at the same rate, they'll click through to the category pages. Again, let's still keep them unsplit. 30,000 people view a product. Again, they're not split. They're still the same group. And now we get to the interesting bit. Some of them add this to their basket and go to the checkout page. So now we do allocate them to group A or group B and show them these two different checkout pages. And we get the same conversion stats as before. And we can do our calculations again, but this time we're doing them on just these 10,000 users. So now instead of measuring 5 to 5.2%, we're measuring 50% to 52%. And this is now statistically significant at p equals 0.05. So in general, you want to allocate users to groups as late as you can. You don't want tens of thousands of users that are part of the A/B test for the purpose of your calculations that haven't actually seen the difference that you're trying to test. The last error I want to talk about is kind of a meta error, and that is not agreeing the setup. There are a lot of things you need to agree on when you're running an A/B test, lots of things you could do one way or the other. These are things like the scope of the test. So what pages are we running this test on? Are we running this on logged in users or all users? If you have a website that operates maybe slightly differently in different countries, are you testing it across some of them, all of them? You need to make a decision on that. What is the goal of the A/B test? What is the most appropriate way of measuring it? Maybe you're running a content site, and so really what you're trying to improve is engagement. But what is a good way of measuring engagement? Is pages viewed per session good, or is that too easily subverted, for example, by just splitting an article into 10 separate pages? Or is average time on site, is that going up good because people are engaging more, or is it bad because it means people have spent a long time trying to find what they want? These are all important conversations to have, but you need to have them now before you start the A/B test, not afterwards. If you have the discussion afterwards, then what you're probably doing is saying, well, I've got results on page views and I've got results on average session time. Which results do I like the best? And then you're deciding the result, not the data. So yeah, ideally, I agree one metric. Try and stay away from people who say, well, the most important metric is revenue, but let's keep an eye on conversion. Because again, you'll come to a point where if you get good results on one metric, but not the other, then you're back to we're just deciding the result rather than letting the data decide the result. So we've got our setup all nailed down. Let's run the test and hope good things happen. The first thing to remember is the test measures the impact of all the differences between the two variants. We, as people, would naturally focus on the intentional differences, the ones we wanted to make. But there's often other differences that creep in. We once ran an A/B test on a mobile commerce app. So it's a fairly standard app. You load up on your phone, it shows you some products. And to get those products, it's talked to an e-commerce web service, which has a catalog in it. It returns products, the mobile phone displays them. And we said, well, this is fine, but those products aren't personalized. We have a recommendation engine which will select personalized products for each user, and it will look the same, but it will do a better job. So these are the two variants. And we think that by showing a personalized set of products, people will find what they want more easily and you'll sell more stuff. So this is the A/B test we thought we were running. Unfortunately, there was a bug in the implementation of the mobile app. The agency that did this introduced a bug that meant that this variant, the variant with the personalized recommendations, crashed 10 times more often. And yeah, when we ran the numbers at the end of the test, the original version had better results. But what we don't know, and still don't know to this day, is were the recommendations the problem or were the crashes? You can't say, well, this variant was 3% better, but given that it had much fewer crashes, then actually maybe the recommendations were really good. It's very difficult to ignore one of the factors. And this is quite an extreme example, but in general, be very wary of any accidental differences between your two variants. One very common one is performance differences. Maybe the new variant loads more slowly because you're doing different calculations. Repeated significance testing. This is an anti-pattern. So something that's very tempting to do is to say, well, we know how to do significance calculations. So what we'll do is every day we'll look at the results of the test. And if the results are not significant, we keep running. And if the results are significant, then we stop the test. And the problem with this is that it invalidates your significance calculation. Because what you're doing is you're re-rolling the dice every single day. And so instead of having a result where you have a 5% chance of it being a fluke, you'll have a much higher chance. It is difficult to resist. People want to know what's going on in general. A lot of tools or platforms tacitly encourage it. They provide you with real-time dashboards to allow you to do this. So it's very difficult to resist. But really, you need to stick to your sample size. Don't even look at things before that. And by the way, this is one of the places where there is a difference between Bayesian A/B testing and classical A/B testing. With Bayesian A/B testing, this is fine because of the way it looks at the numbers. So maybe we've got to the end of the test. We've dodged all these possible pitfalls. What can go wrong analyzing the test? Well, the first thing you need to do is you need to do the maths right. That means using the right statistical test. As I mentioned, if you've got conversion, that's not the same as testing for revenue. That's not the same as testing for retention rates. And not only is it not the same, but it does not follow that if one metric has a significant result, that other metrics will have the same result. Significance on one metric does not imply significance on another. And where I've seen this the most often is people use a tool or a platform that can measure one kind of metric, but you're most interested in a different metric, and you kind of hope that because one is significant, the other is too. That's not right. It doesn't work. Another thing that can go wrong is outliers. So maybe we're a charity, and obviously what we're trying to do is trying to get people to donate to us. And we have this UI which is not very good. Puts users in a slightly awkward place, blank sheet of paper problem. They don't quite know what they should be doing, what the right amount is. And we have this idea that if we show a UI more like this, where we're putting specific numbers, but still allowing free text entry at the end, that maybe people will donate more often and donate more. So this seems like a good candidate for a test. So we'll run an A/B test with these two variants, and we decide that the metric should be the average donation size. So what happens next? Well, enter Bill Gates, noted philanthropist. He comes to your site, so he's put in a group by the A/B test, and he ends up in the variant with the control group, so the free text entry. He's a generous man. He puts in this donation, $1 million, and you're looking for your test at the average donation size, and he has probably single-handedly made the control variant win. So it's up to you to understand whether or not this sort of thing might be a problem. It's sometimes worth eliminating outliers or using a metric which is less subject to this type of problem. So in order to do this, to know whether it's appropriate, you do need to understand the domain. And this takes on lots of different aspects. Once, a long time ago, we ran an A/B test where what we were trying to do was improve the return rate in e-commerce. So when people buy an item, decide they don't like it and send it back. So we came up with an idea of an algorithm that could improve this. We ran the test for a certain amount of time. We waited till we'd collected enough data, and we stopped the test. And then we started looking at the numbers, and they were really weird. And the reason was, even though the test was over, we stopped showing the two variants. Users still had 28 days to return their items. So if we had done any type of significance calculation, then the results we were looking at were just completely wrong. We needed to wait an extra 28 days or whatever the return window size was with that retailer. And this is the sort of detail that you need to understand when you're running an A/B test. You need to understand not just A/B testing, but your domain. But hopefully you're already experts in your domain. There are lots of different ways in which the domain can be important. Some websites are very sort of transactional. People use them once and then they don't come back for a long time. Other websites will have a much more intimate relationship with their user. And if you're in that case, then there's another problem that can happen. So maybe you run an A/B test, and after 3 weeks, you reach the sample size, and you look at the results, and they're bad. So, -4%, -2%, -3%. Overall, this is a result which is negative, and it's statistically significant. But maybe for whatever reason, you forget to stop the A/B test. It keeps running. So what happens next? Now, actually, if we look over the entire 7-week period, the results are actually pretty good. So what happened? Is this just one of the random flukes? It could be. But because you're a site which people use a lot and which people have workflows built around it, when you change stuff like that, people hate it. When people change the hearts to stars on Twitters, everyone hated that. And people hate change in general. Maybe you broke their workflows. Maybe you made them less productive until they got their head around the new UI. But with time, people either forget or they get used to the new UI. And so this area here, this is the adaptation period where people are getting their heads around the new UI, getting to grips with it. And once they did, actually, your new UI was a really good change, but it just took people time to get used to it. And the reverse can happen too. Sometimes a change will make things look better for a few weeks just because of the novelty of it. And that boost is not due to the nature of the change. It's just due to, oh, something new and different. People engage with it a bit more for a bit. The next thing I want to talk about is result splitting. So this is something that can be very tempting if you run a test and the outcome is that there is no difference, or the difference is not what you are hoping for. It's very tempting to say, well, okay, this is the overall result, but what if we look at mobile users only? Maybe the result is different there. Or what if we look at new users? And the problem is you can very often find splits that sound interesting. And quite often you can find one that gives you the result you want if you look hard enough. You know, you're manufacturing a result. Really what's happening is you're taking results that look like this. So, you know, blue and red, they kind of scatter all over the place. They look about the same. And you're saying, well, if I ignore all these gray ones, then red is clearly the winner. You can gain insights doing this. I mean, maybe it is the case that you screwed up the mobile implementation. Or maybe you're testing a new algorithm and older users have more data, and that meant that pages loaded more slowly for those users because the new algorithm does a lot more clever things. But having gained that insight, you can't turn that insight into a test result. Unless you'd planned the splits all along, then take those insights into account and then run a new test with whatever you've learned. Otherwise, as I said, you're manufacturing a result. And the last analysis error I want to talk about is kind of a meta error. It's the fact that we're not neutral. In the trivial examples people give, you know, should the button be blue or should the button be pink? You're not emotionally invested. But in the real world, there's often real work that's gone into the new variant. Maybe you've spent several weeks designing a new landing page, or maybe even months building a new recommendation engine. You want that result to be, you want that work to be worthwhile. You want your work to be useful. You don't want to spend all that time on something and the test comes along and says, well, actually, the old thing was better. And what that means is that if the result is, you know, quote unquote, the right result, we say, yay, we make everyone get the new variant and we move on. But if the result is wrong, that's when people start looking at result splits. They start digging for potential errors. They start saying, well, hey, well, what about this other metric? You know, the results look better over here. And there is no silver bullet here. You have to try and apply the same rigor, whatever the result is. A well-documented test can help in some respects, you know, clamp down on people who try and look at splits or different metrics. But really, you have to keep yourself honest here. So that's it for kind of errors. Finish off with some best practices. I start by saying, try not to reinvent the wheel. So for example, in the Rails world, Split and Vanity are gems that do a good job at managing who is seeing what variant, for example. There are a number of platforms that will run A/B tests for you. So Optimized and Google Optimized, for example, which you may wish to consider. Whatever you do, it's on you to understand your tool, understand the drawbacks. For example, the entry-level tier for a lot of platforms use client-side tests. And that means that the page loads with one variant, and then some JavaScript runs from Google Optimize, and that JavaScript decides, should I replace what the user is seeing with the new variant? And when that happens, it can often be that users see one variant for half a second and then it flashes. And so the new variant users get a slightly worse experience. And that, you know, that can occasionally skew things. So you need to understand things like that. You need to understand, when is it allocating users to groups? How is it doing that? What method is it using for doing its significance calculations? For example, Google Optimize uses Bayesian methods. You should be on top of those things. Resist the urge to check and tinker with things. So that covers repeated significance testing that we talked about earlier, but generally changing the test. So maybe halfway through the test, you find a bug. Obviously, you're inclined to fix it, but if you do that, then your results will be half with the bug, half without the bug. And again, you won't really know what the test conclusions mean. So fix the bug, by all means, but then restart the test. AA tests are a great thing to consider. So an AA test is exactly like an A/B test, but both variants are the same. There's no difference in the content that the user sees. but you still do the same process. You should still be writing down your documentation for the test. What are the scope? What is the metric? It removes any pressure to get a result. So it's a great way of finding weaknesses in how you're setting up the test. And yeah, it's a way of practicing. I'd like to say be wary of over-testing. I mean, maybe I've convinced you that A/B testing is a great thing to look at, but don't take that to the extreme of let's test everything. There are a number of problems with this. I mean, one is that it's very time consuming. If it takes you 2 weeks to get significant results, spending 2 weeks to make every single decision you need to make is just going to take you forever, and you'll fall behind. And the bigger thing is that I think A/B tests are good for guiding you, but A/B tests can't lead you. They can't replace talking to your users and understanding their problems. It's not a substitute for vision. It won't tell you what hits are worth taking in the short term, because although you may make a little bit less money this month, they push your platform or your application forward. And I would say definitely don't fall in the trap of just using A/B tests to represent decisions you've already made. If you really want to do something, then just do it. Don't do an A/B test to pretend that you've done it differently. Make the decision, own it. And then lastly, I think was the most important thing is document your test. Have a checklist every time you do an A/B test, covering things like the metric, how you deal with outliers and so on, the success criteria. So sometimes you do want the new variant to beat the old one, but maybe that's not that important. Maybe you just want to not make things any worse. So if that's the case, write that down. The scope, as we mentioned, what exactly is on the test, what pages, what users, and so on. Do your sample size, test power calculations, document all that. And then how you're going to calculate significance and the process around that. And also pick meaningful variant names. Don't just call them control and experiments. You'd be surprised how easily people can get confused around that. So that's all I had. So thank you very much for listening. I've got some suggested further reading if you want to find out more, particularly about Bayesian testing. But yeah, thanks for listening.